This example here we are going to also solve with the substitution method just as we had done with the previous examples. Although we're going to see with this particular example there's going to be a lot more work and some fractions and things that we're going to encounter. And so if we were to use the substitution method to solve this, the reason why we're going to kind of run into fractions and a little bit more work with this one is because to substitute, you first of all need to isolate one of the variables. That's the first step. And if we're to isolate a variable, we are going to run into fractions because the coefficients of all of the variables, the v's and w's, are not ones nor negative ones, and so we're going to get some fraction sort of stuff. So you just need to pick a variable you want to isolate. Does not matter if you isolate v, nor does it matter if you isolate w. So I'm just going to go ahead and choose this first equation, let's say, and let's choose v, and we'll isolate the v there. So if I'm going to isolate the v in that particular equation, I'm going to first of all add 6w to both sides, and that's going to give me this equation here, and then I'll divide everything by -4. So when you divide 6 by -4, you actually get -3/2 when you reduce, and then you're going to get plus 5/4 because you have a negative divided by a negative there when you divide the -5 by the -4. So that isolates the variables there, and then we can do that second step, which is to actually do your substitution. So what we're going to do here is we're going to take this right here, which is really what v is worth, but we're going to substitute it in for v, and it has to go into the other equation for v right there. So that means that the 3v minus 7w equals 21 equation, that when we substitute -3/2 w plus 5/4 into that, we can now solve for a particular value of w. Now this substitution is going to result in some fraction stuff, but it's really not too crazy. So let's do some simplifying here. So when I multiply 3 times -3/2, we're going to get -9 over 2w, and then 3 times 5/4 will be plus 15/4 minus 7w equals 21. We do have some like terms that we encounter here because on the left-hand side, both of those are w terms. So in order to combine them, we'll need a common denominator. So that -7 right there, if we turn it into halves, it's the same thing as -14/2 w. So then if we do combine those together, you're going to get -23/2 when you combine that together, w, and then plus the 15/4 equals 21. So to get the constants all on one side and the variable term on one side, we'll have to undo the adding of 15/4 by subtracting 15/4. And then that just means that right there, you're going to need a common denominator, so you'll have to multiply by 4/4 to get that common denominator there. So kind of just moving this work over here. Then you're going to have the -23/2 w is equal to, what we get is 84/4 is the same thing as 21, minus 15/4, and then you can subtract those fractions. You end up getting positive 69/4 is equal to -23/2w. So finally, as one last step there, you can multiply by that reciprocal of -2/23 to get a positive w, and then similarly you have to multiply by -2/23 on this side. So you do end up getting -138 when you multiply 69 and -2, and then you get positive 92 when you multiply 4 and 23. It does turn out that both of them are going to divide nicely by 46. It would be the greatest common factor of those numbers there. So it does end up reducing all the way down to -3/2 for a w value. So you do end up getting w equals -3/2. And then now that we've finally got, after a little bit of work right there, one of the variable values, then you can go ahead and substitute in w into one of the equations. So I'll kind of bring that up over here. So I'll pick the first equation, how about? So I'll take the -4 times v minus 6w equals -5, and we'll substitute the -3/2, which is -1.5, into that. So we end up getting then that negative 4v, and then that negative times the negative will be a positive 9 equals negative 5. Then we can subtract the 9 from both sides to give you negative 14, and then you can divide by negative 4 to give you a positive 14/4, but that ends up reducing to 7/2, and 7/2 actually is 3.5. So with that, then we get a v value of 3.5. So now you'd want to check, so you'd have to plug in, I guess, into the second equation just to check to make sure it does turn out okay. So you end up getting those values. So I think typically we probably would go in alphabetical order with v and w. So v comes earlier than w, so I guess you would use 3.5 as your v coordinate and then negative 1.5 as your w coordinate. So that right there would give you the solution to that particular system. Okay. So it does get a little bit messy sometimes when you're using the substitution method, when you have a system where when you solve for one of the variables, you kind of get some fractions and that sort of stuff. It does turn out that when we get into elimination as a method, which we'll get to after this section, that elimination allows us to solve these sorts of systems where you have lots of fractions a little bit more nicely. But just understand that you can always solve systems by substitution, just with some of the examples like this one, just has a little bit more work involved.